name's James Thomas. I'm a developer advocate at IBM Cloud, and I'm also now the lead serverless advocate for IBM's Cloud and IBM Cloud Functions in Apache OpenWhisk, which is a very nice job. And as my t-shirt says, right, yes, I know serverless contains servers. Please don't at me with that question anymore. It just happened far too much. And the title of my talk today is this, right? Serverless, the missing manual, because I want to talk about some of the areas around building service applications and kind of architectures that I think don't always get enough attention when you're kind of reading about serverless online. And it's areas I've seen developers repeatedly struggle with as they attempt to kind of migrate their applications over to these new architectures. So my talk is called The Missing Manual, because I'm going to try and fill in some of the gaps that you might have in knowledge of cloud services and capabilities that I think you're going to need to be productive on serverless cloud platforms. And yes, this is not a real book, although people do ask me where they can buy it a lot after the session, especially on Twitter. And the kind of inspiration for me doing this talk has been my experience of pretty much doing this kind of thing for about the past 3 years. So I've been an advocate now in IBM for a while, and about 2 or 3 years ago, almost exactly 3 years ago, I decided to focus 100% on serverless, just doing more and more stuff. And so I've been going around kind of doing lots of presentations and workshops and meetups for about 3 years now. And I started to notice something interesting, right? When I had gone and done a presentation, you know, kind of finished, people clap, hopefully, and then they ask you questions. And the questions they would ask about around serverless, because they have lots of questions. Serverless is very new, but it wasn't around the things I would expect them to ask. They could kind of understand the basics fairly well, what I call the functions as a service bit of serverless. And where most of their questions came from, I think, was them struggling in their head to translate the traditional application architectures that they knew over to this new serverless world that we live in. And I think the reason that they are struggling, or people sometimes struggle to adopt serverless and think about how to use serverless, is because of this, right? That serverless and service applications, it's more than just files, it's more than just functions as a service. In the same way that all applications are more than just a collection of functions, you need other capabilities of service to make them work. So it means that serverless applications are more than just a FAS provider or FAS solution. And I think when people talk about serverless, you go to conference talks and maybe you read about it online or you follow lots of stuff around Twitter, there's a lot of focus on the FAS aspects of it. What's the correct runtime, how do you bundle your app, all that kind of stuff. I think we don't often talk about some of the broader baseline knowledge that you might need to know to be productive. And I think this is where developers kind of struggle a little bit. So this is my attempt, this talk especially, to rectify the wrong that I think I've done in the past of focusing too much on the FAS part of service and talk about some of those broader things you need to know. And I actually thought a really interesting way to go through this would be just talk about the most common questions that I get asked after my talk about serverless. So the same questions come up again and again and again, you can almost guarantee. And so we're going to run through the 5 most common questions that come up when I've done one of my dozens of talks about serverless cloud platforms. And I'm going to introduce the question. I'm obviously going to tell you the answer, right? So you can kind of shortcut that. But I'm also going to step back and think about, okay, so like why are developers asking this question? What is it about serverless they're kind of struggling with as they're thinking about architectural stuff? So what do you think? You can have to shout out, think in your head. Right, what do you think the most common question I get asked about serverless is when I finish one of my talks? Right? It's not, why is it called serverless? Don't you know it uses servers? All that kind of stuff you have to put up with. No, by far the most common question I get asked about service, and it comes up 95% of the time I've done a talk or a meetup, is this. Right? Where do I store my files in a serverless application, right? Where do I put my files? And people asking me this when you talk to them, people asking me this are coming from the background of, I think, building traditional 3-tier web applications where they have some kind of infrastructure, some VM, they have their web server, they have some static assets that live on the file system, and the web server is going to need to serve those over to the client. And when they hear me say things like, oh, you know, serverless, no access to the infrastructure, no access to the VMs and containers, they think, okay, but where, like, what about no server, no file system? Where do I put my files for a static web application? And people ask, you know, do you build serverless web apps? Is this a thing? And the answer is yes, we do. So where are you going to put your files? Now, before I tell you the answer, I'm going to point out something interesting, I think, about serverless runtimes that many people don't know, and it's actually they do have a file system, right? When your code gets run, is extracted and ran of one of these little container environments. And actually, it has a local file system that it can kind of read and write and interact with from the function code when it gets kicked off. But this temporary file system you get in your serverless runtime isn't a file system you generally use for storage in the cloud for a number of reasons, because it comes with lots of limitations. So it's limitations on things like this, right? It's what I call temporary and limited storage. So any changes you make to that file system long-term aren't persisted. Kind of environment gets wiped out eventually and they kind of disappear. And it's not a very good feature of a file system to not persist changes. We like things that we write to be there for a long time. Also, it's normally limited in size. They're normally limited to around 0.5 GB or something like that, depending on your particular provider. So it's not a very scalable solution for storing terabytes of data in the cloud. Also, your file systems that come in these, the serverless runtimes and your code executes, it's not shared between concurrent requests. So if you've got a concurrent request being processed, they're all using their independent environments, they all come with an independent file system, and you can't use that local storage to kind of share application state between invocations. But actually, one of the most challenging bits about this little temporary runtime is that there's no external access to it. You can't like mount it locally, copy files in, copy files out, back it up, any of that kind of stuff. The only way to get data into it is by including those files within your deployment package, right? Your little zip file you upload to your provider. And that zip file is normally limited to around 48 megabytes, 50 megabytes, depending on which service provider you use. And this is kind of challenging because it's normally full of your code, your application code. You have a lot of space left over for kind of static files. And if you wanted to change it, you would have to redeploy your whole application. So I would say that if you just have some static JSON or something like that you want to include in the runtime, people do just include it in the zip file and then it's available and you can read it. But generally, if you're going to be storing files, static files, things like that for a kind of web application on serverless, what you're going to use is cloud services called object stores. Right? Object stores provide elastic storage in the cloud where you can just upload your files to them and access them on demand, and you don't have to worry about the storage infrastructure underneath. Right? It's a very serverless approach. You don't think about the infrastructure, you're just going to use it as a managed service. And all cloud providers have this kind of solution. Right? All cloud providers have some kind of object store that you can use, and they all work in relatively the same way. So if you're going to go and build a serverless app on IBM Cloud, we have one called Cloud Object Storage, which is the kind of object store solution you'd use for IBM Cloud Functions if you're building on that. And as a category of cloud service, object stores have a number of benefits, I think, over kind of traditional storage infrastructure when it comes to serverless applications. And the first benefit is it has what we call unlimited storage. Unlimited, it's only limited by your ability to pay for it, right? You have to pay for it, but if you've got a big enough credit card, it's kind of unlimited. And this is quite different where you just upload your files to the object store, you can access them on demand, and at the end of the month, you get billed for the amount of data you're storing, the number of requests maybe you're doing, the amount of bandwidth you're using, and you just get a bill from your cloud provider. And you're going to pay for capacity that you use rather than reserving a fixed amount of capacity up front. So with traditional storage infrastructure, you normally have like a fixed amount of space that you provision, you buy up front, and then when you fill it, it's gone, right? With object stores, you just kind of use it and pay for it, which is a kind of service approach to usage for cloud services. Another big difference is how you access those files. So traditionally, again, if you were accessing files on a file system, your code would talk to some standard library, which then talks to the kernel, which talks to the block device and pulls the data back. With object stores, those files are available on just a HTTP endpoint, so you get them, post, and put to interact with them. And the fact that your files are available on HTTP endpoints means that there's a number of nice side effects that you get for free. The first is that you can make your objects or your files public. So for example, if you have some static assets, some HTML, some CSS, some JavaScript that you want to serve to the client, it's going to not really change. Rather than the client, the web app or the web browser calling your serverless function, which calls the object store, which returns the content and then renders it to the client, you can make those files public because they're on a normal HTTP endpoint. The client can access them directly, cut out the need to call your serverless function to retrieve that data. It's more efficient, it's faster, and it's going to save you some money as well because your files are just available on a HTTP endpoint. And you can take this kind of approach of kind of nice side effects even further by actually allowing your clients to interact with that object store directly and upload files on your behalf. So example, if you're building some kind of service application, you wanted the user to upload really big video files to your backend, that were like gigabytes in size, rather than having to work out some kind of nasty hack where they upload them through the cloud function and then it puts it in the object store, you can give your clients what we call temporary credentials, pre-signed URLs. That means they can upload the files directly to your object store and you get a notification, you get an event when it's finished, which is a really nice side effect of just having your files available through a HTTP interface. So when it comes to this question, right, people ask me this all the time, right? Where do I put my files in a serverless app? The answer, fortunately, is very straightforward and simple. You're generally going to use some kind of object store to use scalable storage in the cloud, right, for a managed service from your cloud provider. Now, the second most popular question I get asked, I think, is a slight variation on the first one. And it's this, it comes up like almost as often, how do I install my database in a serverless runtime? Or where do I put my database in a serverless application? And again, when I talk to these developers, they're coming from the background, again, of having some kind of infrastructure they manage, and their web application server lives on there, and they will manually install and manage that database, probably in the same environment, and it will just talk to each other over local host, local port, something like that. And again, if you've got no access to the runtime environment, like how do you install that database? And my answer to this, because it's a slight variation of the first question, I think, is that generally, if you're building serverless apps and you want things like database services, you're going to go and use managed database from your cloud provider, right? You're going to go to a cloud provider's console, you're going to click some buttons, you're going to get access to the credentials to be able to access it. What you're not generally going to do is go and spin up a VM, install MySQL, hire a DBA, and keep them in the basement to look after it, right? You don't want to do that. It's very expensive. And the serverless approach is to use managed services where possible. And kind of managed database services specifically have two kind of advantages when you're thinking about building apps in this serverless way. The first is that there's just no maintenance, no infrastructure. You have to manage the VM. You don't have to worry about upgrading the database. You don't need that DBA in the basement. Get rid of them and save some money. And also the kind of billing model is a slightly more serverless approach. Normally you get billed based on usage, how much data you're storing, how many requests you're doing per month, how many regions you're using and things like that, not on how much capacity you've reserved, right? If you're managing your database yourself, probably have like, some infrastructure and it has a fixed amount of capacity, and then when it's full, then you have to go and worry about upgrading and all of that kind of stuff. So if you follow my advice, right, you go and build your serverless app, you go to your console and your cloud provider, and you want to go and get yourself a database, the next question you're going to have is like, okay, but which one do I choose, right? Because now there's dozens of different options I can provision with like a click of a mouse. Like, what is the most appropriate for a serverless app? And this is just a screenshot I took when I was building these slides of the database section on IBM Cloud. And you can see you can have anything, right? If you want Redis, or you want Mongo, you want Postgres or MySQL, or even DB2. For all your DB2 fans in the audience, IBM Cloud is the place to go. Like, which one should I use? And I'm going to give you some new things to think about, because actually the one you are most familiar with, the one that you've been building with for a very long time, might not be the one that's most appropriate for building kind of serverless applications, serverless architectures. So the two new things to think about are this, right? Event support and scalability. It's really important to think about. So what do I mean by this? Let's start with event support. So if you're thinking about event support, if any of those databases that I just talked about, right, MySQL or Postgres or DB2, you can use from a serverless runtime. So you're building some kind of API handlers which are going to kind of kick off your code, and then the code is going to talk to the database. You can get the client library, get the connection credentials, and go and talk to that. That's absolutely fine. But if you want to be building what I call more complex serverless applications, what we call event-driven architectures, then you actually want to be able to event-driven architecture. You want to have your serverless functions listening to changes in their database and kind of kicked off automatically. And actually, it's only going to be a small subset of the services in your cloud provider's console that are going to support that kind of event support. And it might limit the things that you have available to you. So you need to think about, you want to build kind of higher-level event-driven architectures and think about the services that have that deep event integration. The other thing to think about, which is important, is scalability. So, serverless, one of the benefits of serverless is that it can really bring out the ability to scale your runtimes really, really easily, right? Just make it easy to scale out the runtimes and have loads of stuff executing in parallel. But what that can mean is it actually kind of overwhelms some of those downstream data sources, right? Your database connections, which were built in a time when you had a kind of single long-lived connection to that downstream data source. As we heard in the last talk, suddenly maybe you can't cope with the amount of requests coming in a second and things like that. So you need to think about are those databases that you're most used to able to cope with the kind of scalability and the traffic profile that serverless brings? And those first two questions come up like again and again and again, right, around what kind of application services you need for your database and for your cloud providers, your serverless apps and things like that. The third question goes in a slightly different direction, but again, comes up very commonly, and it's this, right? Can I use framework X with my serverless application, right? And people, when asking this question, they're thinking about things like Ruby on Rails and Spring and Django, and those kind of traditional, what I call web application frameworks, right? And people ask me all this all the time. Can I use Ruby on Rails with serverless and things like that? When people ask me this question about, can I use Spring? How do I migrate my Rails app to a serverless? I normally give a very short and simple answer, right? And the answer is this: no. No, you cannot do this, nor is it possible, nor is it really a good idea. And unfortunately, the problem with this is that people love their frameworks. People are very attached to their frameworks. And when I say this to them, I start to see them sort of like tear up and well up a little bit. I'm going to rip their frameworks away. And I don't want to do this, right? I'm a developer advocate. I'm supposed to make people happy, not sad, developers happy. So I think about like, okay, why do I say this to developers when they're always asking me about using frameworks and serverless? Like, what do you need frameworks for? What do frameworks do for you in this new serverless world that we live in? And I think, if you take all those, I'm talking about those big traditional web app frameworks, right? Things like Rails and Django and Spring Boot. I think there's some common tasks they do, regardless of their kind of language or runtime. And those common tasks are things like this. They do things like scaffolding and boilerplate. It's very, very useful to be able to type a command and get a new serverless app up and running really, really quickly, or a new web app up and running really, really quickly. They also do things like request handling and URL routing, right, where your framework will listen on the HTTP port and then work out which bit of your application to call. Authentication and middleware. Normally the framework makes it really easy to add authentication across all your API handlers. And the same with middleware, right? Normally have some kind of plugin architecture where you can go to GitHub and get loads of third-party plugins to do things like cause and rate limiting that you might want on your API handlers without having to manage any of that kind of stuff yourself. And the same goes for what I call service credentials, right? Hopefully we know it's a bad idea to hard code usernames and passwords all over your application, right? Who's ever done that and checked into GitHub by accident? And normally the frameworks have a way to kind of, you give the credentials to them and they inject it into your runtime environment. And then finally, packaging and deployment. Normally the framework will have one command where you can start everything locally in testing and development, which is nice, and then also kind of develop your kind of deployment package and push it over to your cloud provider. Right? That's kind of useful. And this is why frameworks traditionally have been very popular, I think, those traditional web app frameworks. But I started to think about, like, what do frameworks mean in this new serverless world that we live in, right? Are all those tasks still relevant? Are they still the domain of the developer or some open source framework? Or actually, are they kind of managed for you by the platform? And it turns out many of them just kind of come automatically built in as platform features. So for example, right, if we think about things like request handling and URL routing, if you're building web API endpoints with serverless, you're going to have, the way you expose those to the internet is using an API gateway service, right? And the API gateway has things like request handling built in. That's its kind of job, right? It's going to work out which cloud function to call when the API request comes built in. So you don't need some open source framework to do that in your kind of deployment, your business logic. The same with things like authentication, right? API gateways make it very, very easy to just tick a feature flag and turn on OAuth with your identity provider across all of your request handlers, right? That's what it's kind of there for. And the same with middleware. Many of the common middleware packages that you might get for a web app framework are just feature flags in your API gateway. If you want cause or rate limiting, you can just go in and flip the flag and turn it on, basically, and just integrate that out of the box. So again, that's not really something your business logic has to do. And then finally, service credentials, right? Service credentials basically come built in. All service platforms have some mechanism where you can give your API keys over to the provider and it will automatically inject it into the runtime environment. So looking at these things, right, these tasks that they did for us, it turns out that many of the features that those web app frameworks handle for you are kind of baked into the platform, right? It's redundant. You don't need a framework to do this. But there are some kind of things left that serverless can kind of help with, right? Some space for frameworks to come along. And I think those two big ones are scaffolding and boilerplates, right, to get started with a new serverless app up and running very quickly. And then also packaging and deployment to be able to type a command and generate your deployment package, maybe do some local testing, and then push it over to your cloud provider and hook up all the event sources and the gateway and that kind of stuff. That stuff is still quite low level and complicated today. So although the traditional web app frameworks aren't relevant anymore, I think there's space that new frameworks have kind of come into. And it turns out loads of people have been writing frameworks for doing serverless development. You can kind of try out today to help you with some of this kind of stuff. And if you want a tip, this is my tip, go and check out one called the Serverless framework. It's an open source CLI tool that handles those two tasks for you. It's the biggest and most popular serverless framework project out there. It's got like 20 million stars on GitHub and all of that kind of stuff. The nice things about it, it's what I call multi-vendor, so it's not tied to a particular service provider, supports pretty much all of them. And it's also language agnostic, so you can use it with Java or Python or JavaScript. It just works really, really well. And it just does those two things for you. You can type a command to spin up a template app locally. You can do the kind of testing and development. You have a little YAML file that describes your application config, and when you type deploy, it will go and set it up with your cloud provider. And I really like it. It's open source. Other frameworks are available. Okay, so penultimate question now. And this comes up again and again. It's a bit of a sore point for developers in the serverless community at the moment, right? How do you debug serverless functions? How do you debug serverless functions, right? And I think people ask this question because they realize that the obvious challenge here is that with serverless environments, you have no access to the runtime environment, right? So all those tools, you can't SSH into your cloud function and grep through the logs and work out what's going on, right? Any tools that you have that rely on having access to the environments, like attaching debuggers and things like that, are just not going to work in serverless because you have no access to the infrastructure and the environments running your code. But since I'm still going to be writing my application, even if I'm using some magical serverless platform, right, there's still going to be bugs in there because I'm still human, right? We're going to still have to debug stuff in production. So I want to talk about some of the basic tools that you still have available to you to debug things when they're going wrong on serverless platforms. And the first thing you'll have is access to logs. So it turns out, I think this works quite well in serverless. Anything you write to essentially standard out or standard error automatically normally gets captured by the platform. So it gets captured by the platform and normally are made available through some platform API. And then there's normally some kind of logging service integration that comes in there to send it over to some managed log service in the cloud. So in the service app, you just need to make sure your service function is very important to have good logging throughout that you can kind of fiddle with a feature flag and things like that. And I think this is actually a much nicer approach than traditionally how we've done log management in the cloud or with kind of traditional infrastructure where your application writes to a file on disk, and then maybe you have some kind of cron job which has to rotate it so it doesn't get too big. Then you have another cron job which maybe sends it off to some external logging service. Then you have some kind of monitoring infrastructure to make sure that is all working. With serverless, logging kind of comes built in for free. You just log to standard out, standard error. It's captured for you by the platform. And so, for example, right, there's a little hello world running on IBM Cloud Functions, and you can see when it runs. I've got a function called main. I've just got those console.log, console.error lines, and when it gets invoked, they're automatically captured and made available through the platform API, which is very, very nice. And then we integrate it, we send it all over to Elasticsearch and Kibana. So IBM Cloud Logging is our managed logging service in the cloud, and all of our service logs get sent over there. So we have a nice centralized place to be able to search through them, set up dashboards and monitoring, alerting, and all of that kind of stuff. And this kind of comes built in for free, which is a nice thing about service logging, just comes part of most platforms. Another thing that you kind of get built in for free is normally some kind of high-level metrics about your functions being invoked, right? What functions are invoked? When did they get invoked? How long did they take? Did they return errors? Did they return success? All that kind of stuff. Maybe some stuff about cold starts, depending on your platform. And these kind of high-level metrics are just kind of built in automatically, which is very, very nice. It's not something you have to kind of pay for or set up yourself. And you can use these to start to diagnose when things are going wrong. So for example, if your functions start to return errors, maybe that's an indication that things are going wrong. Or if the duration starts to get really, really long for your functions, maybe one of your downstream services is struggling to cope or something like that, which is nice. And again, most of the cloud providers will send all these metrics data over to some kind of monitoring service so you can set up dashboards and alerting and things like that. Now, sometimes when I mention this kind of capability that you get kind of some high-level metrics automatically recorded by the platform, people normally ask, well, what about things like custom metrics, right? What about more advanced runtime checks that I want to be able to include? Maybe things that are specific to my application, or maybe just more things from the runtime, like garbage collection or CPU or memory usage, how would you record that, maybe if it doesn't come built in with a platform? And the challenge here is, I think traditionally how you've recorded this stuff is by having some kind of background agent that you install into the environment and that will run in the background all the time, polling and sending that data over to your metrics infrastructure. And the challenge here is that you can't get access to the runtime environment to install your background agent. So what do you do if you want to capture this stuff? And the trick or the strategy, if you want to call it, that the serverless community has kind of worked around for this kind of stuff is this. If you want to record custom metrics, what you do is you have a runtime library that essentially, when your function's invoked, it will just log them to standard out or standard error, which means that they're automatically captured and made available on the platform through the platform API. And then to simulate having a background agent, you have another function that runs on a cron event, a timer event, kind of runs every 5 minutes or every 10 minutes, and essentially just pulls all the logs available from the platform during that interval. It's going to pass out all those metric values, and it's going to automatically send them over to your logging infrastructure. So you kind of simulate having a pseudo background agent by having another function that runs on a timer that does that integration with your custom metric values. And actually use this approach to an application I was building, a little Node.js application, well, I wanted to record all the kind of stuff about like CPU and memory and garbage collection. So I had a runtime library that was just logging all of that stuff to standard out, and I had another function which was kind of running on a timer every 5 minutes. It was pulling all the data in, passing those out, and pushing it to a service we have called IBM Cloud Monitoring, which is just hosted Grafana, right, the popular open source package. And then I could set up all my dashboards and alerting to get me out of bed if things started to go wrong. Now, like if you are debugging, thinking about debugging serverless apps, the kind of basic tools you're going to be using primarily are things like logs and metrics and monitoring. And this can seem kind of primitive to you, right, if you're used to very, very expansive tools that you can get access to. And so if this kind of puts you off, right, you think this is kind of something to be a bit wary of serverless, I would kind of say just like hold on a little bit, because all of the platform vendors understand this pain, right? Debugging is a big pain point for developers, and they're working on much better tooling. So I think if you skip forward a couple of years, you'll have much better tooling allowing to attach debuggers and stuff like that. And some platforms have started to play with this kind of stuff. So I think in the future it's going to get much better, but it is a bit of a pain point at the moment, and you're going to be much more restricted to things like logs and metrics that the platforms collect. Okay, so final question now, and I think that the final question I'm going to talk about is something that developers worry most about. They seem most worried about in their face when they're kind of asking me this question. And the question is this, right? Can you set a limit on costs for your serverless application, right? Can you set a limit on costs? And again, I think when people are asking me this, it's because when I'm on stage saying, you know, serverless is wonderful, it's elastic compute on demand, it's as much capacity as you need, you just have to be able to pay for it. They think, well, what happens if I build a little app and I put it online and it gets onto Product Hunt or Hacker News or Slashdot, it gets massive amounts of traffic, and if I had a little server, it would just like crash and set on fire. Now it's going to work, but I'm going to get a massive bill from my cloud provider at the end of the month, right? It's going to bankrupt me. Like, what about that, right? And they worry about this. They really seem very concerned. And I think sometimes people think if we get more people adopting serverless, you're going to see scenarios like this. We see developers in Silicon Valley panhandling in the street saying, please help me. I accidentally wrote a recursive service function. Now I need dollars for my cloud bill. Right? So the thing is this a realistic scenario? You're worried about bankrupting yourself with serverless? Like, is it just a ruse from the cloud providers to get you to spend more money accidentally? Like, no, don't say that, no. And also, what can you do to mitigate this risk of accidentally spending too much money using serverless cloud platforms? And I think the first thing to say is that serverless platforms do have limits, right? You know, it's not unlimited compute. There is physics and there is servers and all that kind of stuff. But especially as a new user, when you go and sign up for an account with your cloud provider, they will normally limit the amount of capacity you can kind of use out of the box. And there's two things they kind of limit you on from the beginning. The first is what we call concurrent invocation. So how many functions can be executing at any one time? And most of the providers limit you to around 1,000 concurrent invocations when you kind of sign up. And if you try and invoke 1,001 functions at the same time, that final one just gets kind of killed off and they return an error and say rate limited, right, come back later. And this obviously stops you accidentally using too much traffic too quickly. Now, this is what I call a soft limit. Most providers, this is a soft limit where if you raise a ticket in your help console, they will raise that for you so you can do more kind of capacity. But out of the box, that's quite a lot, 1,000 concurrent functions. The other thing they kind of limit you on is time. So when your serverless function gets invoked, you have, depending on your provider, between 10 and 15 minutes to process that API, that event request. And yes, it's 10 or 15 minutes. And so, for example, if your function is just runs and it hasn't finished after 15 minutes or 10 minutes, the provider just like kills it off and returns an error code and said like took too long. And so if you were to push up a little function that like had no return statement, like never returned, you ran it, it doesn't just run forever, you know, creating a constant stream of revenue for your cloud provider, right? After 10 or 15 minutes, it's just going to get killed off and it's going to return you an error. This, as I understand it, on all providers, this is a hard limit, so they won't allow you to raise this kind of built into the platform. So you kind of have to build your architecture around this kind of stuff. But yeah, so those two things, the concurrency limit and the time limit, are probably, you know, enough to stop you running up the bill the size of a small country's GDP. But maybe it's still enough to bill, you know, to bill like, you know, enough money that might hurt you or your company. So what kind of practical things can you do to kind of limit a little bit your exposure to some of the costs that you might run up? And the first thing you do is configure rate limiting for your public APIs. So if you are building completely public endpoints, right, I think it is a legitimate concern. If you build completely public endpoints that anyone can access, maybe accidentally or maliciously, people might send you too much traffic, right? Too much traffic and do a kind of financial denial of service attack. But if you're building public endpoints, the way you expose them to the internet is through those services called API gateways. And the way that API gateways work is that they have rate limiting built in. This is just a feature flag. So you go into API gateway, you can turn the flag on, you can set no more than 1,000 requests a minute or something like that or less. And if it gets more traffic than that, it gets more requests in, it will just turn them back with a rate limiting error. It's not going to invoke your serverless function. It's not going to cost you anything, right? Especially on the serverless side. So this is a really like practical and sensible tip. If you're building public API endpoints, always turn on rate limiting. It's a really important feature to include. And another thing you can do, another kind of defensive mechanism, is to turn on billing alerts from your cloud provider, right? So normally in your cloud provider's console, you'll be able to go in and set an estimated monthly spend or something like that. And if you start, so your projected spend goes above that, they will start to send you notifications to go and turn things off, right, or see what's going on. And again, this is a really, really sensible thing to do. You know, I'm sure it looks like this in other providers, but in the IBM Cloud Console, you can go, okay, no more than $100 a month on services or applications, and then we'll start to send you lots of notifications to turn things off if it starts to go above that, right? So that's another kind of defensive mechanism you can put in place to accidentally not go too much. If you're using serverless, they come with a big free tier, so that I do, where I don't want to spend like a cent basically every month because I don't want to get out that free tier. So I have a billing alert set up that if I go over that, it's going to start to send me notifications. Now, these questions I get asked, right? These 5 questions are most genuinely the most common questions I get asked about serverless still to this day when I'm going speaking to developers about using serverless cloud platforms. But people have loads of really, really other good questions about serverless that I've not got time to even get into. There's things like, how do you test serverless applications? This could be a whole conference talk on its own. I think there is a talk at this conference about that, so go check it out. That's a good question. How would you do dev test to production? How do you set up your kind of deployment workflow when you don't have any infrastructure at all? It's all virtual environments. And also, when should you not use serverless? When is it not appropriate, right? You know, when is it, just not appropriate to use, right? What workloads doesn't it work for? And these are all really, really good questions. But since you don't want to listen to me all day, I was kind of thinking about what general advice can I give to people about using serverless to help them like answer their own questions about building applications, to be their own Stack Overflow, right? Since that's what we'll use. And I think the best advice I can give to people about using serverless is this, right? Is remember to be lazy and embrace the cloud as much as possible, right? I think that's why I like serverless, because I'm pretty lazy. So I'm happy to embrace the cloud. And I think the reason I say this is that when you're building, you suddenly realize when you start to build serverless applications, often you're just building the kind of integration or the glue between different cloud services. Often we describe the FAS part of serverless as that glue between different cloud services. And so when you start to build applications and you start to run into some of these issues around like, oh, well, how do I do my log management? Like, how do I install my database? Where do I store my files? Where's the file system? The best approach, I think, and a kind of serverless approach, is to be lazy, to think, okay, can my cloud provider do this for me? Does this come built into the platform? Is there some kind of service I can provision and manage? Does that work? Is there some external API or service or SaaS provider I can manage to use that I can just integrate in? And to get away as much as possible from thinking, well, I'll spin up a VM, I'll run some infrastructure, I'll manage myself, I'll use Kubernetes, right? Get away from managing stuff yourself and move up to just integrating different cloud services. So I think if you can remember this advice, right, of being as lazy as possible and embracing the cloud as much when you're building serverless applications, you will go a really, really long way to answering your own questions. Thank you very much.